Hi everyone. Uh, Today I'm going to explain Experiment 9 collaborative process synchronization using Semaphores and shared memory from Unix and Linux lab. The objective of the experiment is to implement inter-process communication using shared memory and Semaphores. The prerequisite are to like what is the process synchronization, what are the critical section, basics of IP mechanisms, and what is shared memory. Shared memory is a method where multiple users process access the same memory space. This is passes IP method because process directly read and write data. Some forms are used for process synchronization. We'll directly go on to the first question. The first question is to write a program to implement mutual exclusion for shared resource in your team using Semaphore. In this, we implement mutual exclusion using Semaphores. This ensures that only one process accesses the shared resource at a time, preventing data corruption. So this is executed in the C file and the output has been shown here. The second question is to simulate a read and write a problem related to your theme using Semaphore and shared memory. In this process, this simulates multiple reader can read data, but only one writer can write at a time. Some of us help manage this efficiently. The third question The third question is to create a memory segment where multiple processor write and read theme related data synchronizes access using Semaphores. Here, multiple processors read and write data using shared memory. Semaphores ensure proper synchronization. The fourth question is to implement a program to calculate the total inventory or count of item in your team using shared memory. A shared memory is used to store value. Process calculate total count and inventory value. Here, the inventory value is given as 200. And then to demonstrate how the fifth question is to demonstrate how Semaphores can prevent deadlocks in team-related operations. The Semaphores are used carefully to avoid deadlocks. Deadlocks happen when process wait infinitely. And the sixth question is to write a program to clear and delete a shared memory segment related to a theme. Here we use shmtd, that's detach, and shmctl to delete memory. The seventh question is to simulate concurrent update to a shared resource in your team, ensuring consistency in Semaphores. In this, multiple process update shared data simultaneously. Semaphores ensure data consistency. The eighth question is to develop a program to calculate display aggregate data using shared memory. In this, we calculate total sales or total record using shared memory. The ninth question is to write a script to implement and test Semaphore operations. So in this ninth question, we test P operation, that is wait, V operation, that is signal, to understand synchronization. So the last question is to create a program to log all read and write operations performed on shared memory related to your theme. In this program, we create a program to log all read or write operation, track how shared memory is succeeded. Finally, the result of this experiment is to program were executed successfully in Ubuntu Linux. Processes were created using a fork. Synchronization worked correctly using Semaphore. Shared memory communication was achieved. Thus, we successfully understood process communication and synchronization in Unix and Linux. Thank you.